Hello, Year 9, another exciting day, another day where we can do some maths to make it even better. This is our fourth exercise in Chapter 5, and we're looking at perimeter as well as area of things that are known as composite shapes. Now, if you take three different shapes and join them together, you can actually create a new shape. So you can see my three shapes hidden in amongst here. So those three shapes are my composite shape. Now, in this exercise, we're going to be using composite shapes, so we're going to be breaking them up into parts. And treating it as a whole shape. Let's look at our first example. Now, this example says to find the perimeter as well as the area. So there's two parts here that we're going to deal with. Now, two parts that we're dealing with. So the first thing we're going to deal with is the perimeter. But let's look at our shape. It's not a regular shape, but it appears to be a rectangle and two half circles. So really it's just a rectangle and a complete circle if I break it up like that. Now to find the perimeter, I want the distance around the outside. I've put the red marker there. Inside, I can see there's a rectangle. I've shaded that in blue, and I've got two half circles. I've shaded those in a yellowy colour. Let's now focus on moving that rectangle across so I can look at it. And looking at those two half circles, if I join them together, they make a full circle. I've left the red colouring. That red colouring came from around the outside of the shape. So the perimeter around the outside would be add that straight line up, which are these two bits, as well as that half circle and that half circle, which combine to make a full circle. Area-wise, it's the area inside this rectangle, which is the blue shaded part, and the area inside these two half circles, which is the full circle part. So, let's write down what we know. We know that the straight line bits are 100 metres, because it says it here. We know that the circle or the half circle, the semicircle, is 45 metres across, which means the diameter would be half, or the radius would be half of 45 metres, 22.5 metres. So there is our radius. So let's deal with our perimeter. Now I've written a very technical term here. The perimeter of this shape is the straight bits plus the curved bits. Well, the straight bits are easy. That's the 100 plus the 100. The curved bits come from the circle. So it's 100 plus 100, they're the straight bits, plus the circle. Now I could use 2 pi r, or I could use pi d. I'll use pi d, pi times the diameter, which is 45, and put that into the calculator, and it's about 341.4 metres. You don't have to write this straight bits plus curved bits. I'm putting that there so you can see what I'm actually thinking of. Notice I've used brackets. My bracket here says that's the straight bits, and this bracket here says that's coming from the curved bits. That's how I can identify the difference between them as I'm going through if I want to go back and check something. Now the area. The area is going to be, in total, the area of the rectangle, that's the blue shaded part up here, and the area of the circle, that's the yellowy shaded part here. Well, the area of a rectangle is length times width, and the area of a circle is pi r squared. So 100 times 45, because I know that that's 45 there, matches up. Pi times 22.5 squared, I know the radius is that, put it into the calculator. My area is 6,090.4 square metres. Let's try our second example. Now, this is again a composite shape. It appears to be made up of a half circle and a triangle. Find the perimeter. Well, I'm going to put a red line around the entire shape. That's the perimeter that I need to find. And find the area. Well, I'm going to shade the inside of them. Those two colours represent the areas that I need to find separately to add together to get the total area. Let's break up each shape separately, and you can see what we're actually doing here. So, what I'm going to do is recognise first up that I actually don't know any of the dimensions about the half circle, my semicircle. I don't know that length, which is a shame, but I do know this triangle is a right angle and I do know Pythagoras' theorem. So, in order to find the diameter of the semicircle, I'm going to use Pythagoras' theorem. And if you write it out the long way, you can use this, but I like to go d equals the square root of these two sides squared and added together. About 8.94. I've taken it to 2 decimal places. So, the radius, that's the diameter, that's all the way across my half circle. The radius would be half of that, which is 4.47, if I round it to 2 decimal places. Let's find the perimeter of the composite shape, or composite shape, depends on how you like to say it. Now, we've got some straight bits and some curved bits. The straight bits are on the triangle and the curved bit is the half circle. So the straight bits are the 8 and the 4. We can see that on the red line here and here. The curved bit is half a circle. So instead of writing pi times d, because that will give me the distance around a complete circle, I've written a half of pi times d because I only have half of a circle. I only want half of the circumference. Put that into my calculator, or before I do, what's d? D is the distance across the semicircle, which is 8.94. So I can put that all into the calculator and I get an answer of 26.04 centimetres to 2 decimal places for my perimeter. Let's find the area. Well, the area is going to be the area of this golden or yellowy part and the area of this green part, the area of the triangle and the area of the semicircle. Now I know the triangle is a right angle, and because it's a right angle, the base and the height are 4 and 8, which is good. So when I look at that, I can go, area of my triangle is a half of the base times height. The area of a semicircle is half of the area of a circle. The area of a circle is pi r squared, so half a circle would be a half of pi r squared. Put this into my calculator. Base times heights, 8 and 4, doesn't matter the order. You could put 4 and 8 or 8 and 4. Half times pi times the radius squared. I know the radius is 4.47. I figured that out earlier. Put that into the calculator. And the area of my composite shape is 47.39 centimetres squared. Let's go to example 3. Find the perimeter and the area. Well, perimeter is the distance around the outside. There it is. Now the distance around the outside appears to be made up of just 3 half circles. I don't need to worry about the triangle when I'm dealing with perimeter because the triangle is inside my shape. So when I'm dealing with area, I'm going to have 3 half circles as well as a triangle. Well, let's think about these individually. There's my 3 half circles and there's my triangle. Notice I kept the red line around the half circles. The red line represents the perimeter. There's no red line on the triangle because it's inside my composite shape. But I will need this bit to find the area, not the perimeter. Now, do I know everything? Well, let's have a look at what lengths I know. I know the distance across each half circle is 9. So the diameter of each half circle is 9 centimetres. I also know, because these have got these triangles, or the triangle has single lines, that each side of the triangle is 9 centimetres. That's good to know. Let's find the perimeter now. Now the perimeter is a straight bit plus the curved bits. Well, there are no straight bits for this one. I don't have to worry about it. It's just the curved bits, which are those 3 half circles. So there's no straight bits and there are 3 half circles. The distance around one circle is pi times the diameter. The distance around half a circle is a half times pi times diameter, and I have 3 half circles. So I can go 3 times a half times pi times d, which I know is 9, put that into the calculator, and the perimeter of this composite shape is 42.41 centimetres if I take it to 2 decimal places. Now the area, a little bit more challenging for this one. The area of the triangle plus the area of my 3 semicircles. Now the area of the triangle is where it gets tricky because I actually I have a base, I don't know its height. That's a problem. So half of the base times the height's the area of the triangle. I have area of a circle is pi r squared, but these are half circles, so it's a half lot of pi r squared, and there are 3 half circles. Now, I know the radius of my half circle is going to be 4.5 because that's half of 9. It's my triangle that's causing the problem. So let's think about this triangle, and we can actually create a vertical line there. That's going to, because this is an equilateral triangle, it's going to mean that side's 9. This is now half of 9, which is 4.5, and that's the height of the triangle. I've got a right angle triangle. I'm going to use Pythagoras, where I'm finding one of the shorter sides. So this will be a minus question. So if I do this, I'd go straight to that one there. 9 squared take 4.5 squared is 7.79 if I take it under the square root sign to 2 decimal places. Now where I see the height in the triangle formula, I can put 7.79. So let's put the values in. So half of 9 times 7.79, or 9 times 7.79, plus 3 lots of a half, because these are half circles, pi times the radius squared. That into your calculator, which means the area to 2 decimal places is 130.48 centimetres squared. Much more challenging question, and it's got to be broken up into lots of little parts, but hopefully that made sense to you. Now time for you to try doing some. As always, enjoy. Bye for now.